Hey everyone, my name's Adam, and in this video we're going to talk about a language comparison. Don't worry, no languages, feelings were hurt, I hope, and how Finn kind of fits into this. All right, moving on to the next slide. Sorry. Where are we? We're in video 5 of 6, and yeah, if you want to see previous videos or even jump to different sections within this video, check out the description for timestamps and links. Experiences may differ. I've programmed on quite a few different languages to varying levels. I'm not an expert in really any of them. My largest expertise would be in C, being an embedded developer. But yeah, your mileage may vary. Yeah, feel free to chime in with your experiences. Okay, so instead of creating Finn and all the things that I've proposed so far, why not just use C++? C++ is arguably incredibly powerful in specifically highly skilled or trained hands. That said, C++ can be highly destructive to projects with inexperienced teams. And this is something that I've seen in my own I've seen in my own experiences in life too. C++ is fantastic when you're the one doing everything. You know, you stick within one programming paradigm, you stick with, these sets of features. But when deployed across a team, it can go poorly. And because C++ is so powerful, it's almost like you can create your own language inside C++ that is hard for other people to follow. And yeah, basically there's no shortage of C++ criticisms, horrific compiler errors, really poor refactoring, which is improving in some regards, but let's talk on the poor C++ toolability and refactoring. Yeah, don't just take my word on it. Herb Sutter, a guy who is an expert. If you haven't seen him before, there's lots of presentations he's given at C++ conferences. Anyways, he's an expert. He's working on a new C++ variant called CPP Front. You should check it out on GitHub. It's quite interesting. And his goals as a C++ expert is, how do we make something like TypeScript for C++? We want kind of like how TypeScript is to JavaScript. He wants CPP Front to be that to C++. So CPP Front, he wants to be 10 times simpler, 50 times safer, 10 times more toolable. And I totally agree. This is a worthy goal. I'm really glad he's working on it. And I think it's really needed. Finn is specifically more for like embedded systems, not really trying to be the language for everybody. So yeah, I'm excited to see where CPP Front goes. That said, it's also very experimental, which he's very upfront with on GitHub, and it might be years before it's usable. That's too long for me. I want to have something that I can use soon. Now, one place where C and C++ tools really fall down is when you have multiple projects and you want to refactor something. So if you have a mono repo with multiple projects that share some common code, it might look a little something like this. So we're still within one repo, one kind of master directory. We've got some common controller code in here, and it's got a data struct with a field count, and it also has an error info struct with another super common name count. And then there's another directory with its own project and makefile for like controller type 1. So maybe this one has lots of IO, and there's controller type 2, which is like the mini-me. It's got less IO. And they have their own projects and makefiles. Now, even modern tools have a hard time trying to rename count in this situation here. It's all still the same usage of this structure in this field, but sometimes it'll pick up usages of this error info count, which is annoying. But the situation gets way worse when you add more projects, more makefiles, and some of those projects sometimes will have different definitions for data. So this one, it links in one with a int64 count. And what really should be a simple rename refactor, like we want to make this a more useful name, like burrito count or something like that, or count of something. It should just work, but it often introduces bugs if you're not very careful. And if you're relying on some of those interesting, interesting, but also cringeworthy processor hacks and tricks to try to get around some ways of like making things more testable, honestly, the compiler is in for a real rough time. And even if it does get most of the refactoring of this name or a function, my experience is if the preprocessor is involved, you're going to have to do all of that refactoring by hand. Now, this is actually a very difficult thing. It's not like tool authors are being lazy. It's honestly a non-trivial problem. In some cases, I would say it's actually impossible. And that's a challenge that's inherent with C and C++. It's kind of like this crazy Rubik's Cube here. Except that one's solvable. Some of these problems with refactoring are not solvable. So trying to rename a field or a function, and you've probably had this before where the IDE brings up a large list of potential matches. And if you're in a small project, maybe that list is only like 20 or 30. If you're in a larger project, you're probably going to just live with the crappy name. Live with the like unhelpful field or function name because you're worried about breaking stuff in one of those projects. Like if the IDE tells you, hey, here's 88 or 120 different potential matches, please check every single one of them. More often than not, you're just going to live with suboptimal code. You'd like to rename it to make it more clear, but it's just not worth the cost. However, with Fin, we get that fearless refactoring. It's fully accurate. It only takes a few seconds, and yeah, it's great. Now, I've been talking about C++ IDEs and tools in general. How does the best C++ IDE in the world fare? I would probably say that is C Lion at this point. How does it solve this problem? It doesn't. It hasn't figured it out yet. If you look at this request, it was open 9 years ago, and it supports multiple projects. And there's some clarification here. Do you mean to have an ability to perform IDE actions like lookup, navigate, and refactor on several projects at the same time? And they say yes, mainly because I usually develop both the libraries and the apps. This is a really needed feature for at least the embedded devices world, which is what we're talking about here with Fin. So yeah, non-trivial, very difficult problem. Well, then some other people will say like, refactoring is for wimps. You just write your program right the first time, right? Yeah, refactoring code, boo. Get code working, never ever touch it again, finger guns? Maybe. Different approaches to programming though, this really doesn't fly. So if you're following TDD, which I think is a nice idea, I don't fully follow it. It's, sometimes I do, sometimes I don't. Refactoring is key to TDD. You've got your red-green refactor cycle. And this is another phrase from James Grunning. I really love it too. Software should be soft. It should be easy to change. It should not be inflexible and rigid and difficult to maintain. And I would say that improving code is necessary to living a good life as a programmer. So the better your refactoring, the better your life as a programmer. Now, what about some other languages for embedded? Well, very few of these languages that are coming out these days are designed with embedded systems in mind. It's just not sexy like the web, or I don't know, the web, or maybe the web. Yeah, all right, that's right. Most people are chasing where the money is. There is money in embedded systems, but it's not sexy like all the other things. And yeah, most modern languages are way too heavy and or require some sort of garbage collector or interpolator or something like that. There are a few really interesting ones, like Rust and Zig, that target LLVM, but many embedded targets are not supported and will likely never be supported. I know that Zig is currently moving away from LLVM, but yeah, it's not an option for me as somebody who wants to write embedded code that I could take to any architecture. I really want to be able to compile it to C for embedded systems to ensure that I can be portable, I can run it anywhere that I need to. Now, some of these languages can compile to C, but it's not easy to understand. So, like if you generate to C and it looks like obfuscated or assembly in C, when it comes time to debug that on target, because it's gonna happen, you're in for a bad time. Yeah, so that's basically the gist of like one of the main drivers behind Fin generating high quality, like one-to-one translation of your Fin code to C99 code. And I actually think there's a lot of benefits to compiling to C, not just because we want to be able to support any embedded architecture. Yeah, it's not a bad thing. I would say it's a good thing. It's not a bug, it's a feature. I'm not lazy, I'm good. Sure. So some of the most powerful parts of languages like C++ and Rust, they feel like freaking magic. You write a couple characters here and then boom, it does some wild stuff and you're like, wow, that's pretty powerful. On the other hand, though, it can be really difficult to understand what's actually going on, like underneath the covers. And with Fin, if there's ever any uncertainty like, hey, how is this implemented? You can just look at the super readable C code. You don't have to delve into assembly. You can easily audit and understand exactly what's going on. And yeah, there's a lot of tools that are built for C already, like existing analysis, static analysis, and other tools. We can keep using those. All right, so we made it through the language comparison. I hope I didn't tick anybody off. I think every language has its purpose and place and things that it's good at and weak at. I think, however, that there isn't a real good language for cross-platform, like multi-architecture embedded development. All right, thank you very much. Catch you on the next one.